Today we're going to check the math problems for checking the solution for our system of equations. So here we have an example of a system of equations. Now if you remember, the first thing we had to do in order to plot our system of equations or graph them was to solve for y. So I'm going to come over here off to the side, and my x minus y equals 3. In order to solve that for y, we're going to subtract x from each side. So I have negative y equals 3 minus x. Remember that you cannot combine the 3 and the negative x because they're not like terms. Next thing I need to do is divide by that negative 1. I have to get rid of the negative sign. When I divide by negative 1, it changes the sign of everything in the equation. So there's my first equation. It's actually x minus 3. Okay. Now the second equation, we're going to do the exact same thing. So I have the 7x minus y equals negative 3. Let me put a little box around that so I know it's one of my equations. We're going to subtract that 7x to move it over to the other side. And then divide by a negative 1. So I get positive 7x plus 3. So those are my two equations. The question is, what is the solution to my system? So I'm going to turn on my calculator and go to y equals. And let's plug in each one of these. So I have x minus 3. And then on the second equation, it's 7x plus 3. And we're going to go over to our graph. Now we might have to zoom in or zoom out, but we're going to wait until it graphs nice and pretty. And I can see that this point looks like it's at negative 1 and maybe negative 4. So I'm going to put negative 1, negative 4, and I'm going to put a question mark because I'm not certain based on the graph. So I'm going to go look in the table. And this is what we look for in the table. We're going to go to our x value at negative 1. And for the x value of negative 1, look at the y values. Do the two y values equal each other? Well, they're both negative 4, so this is the solution, negative 1, negative 4. Any other point on here, the x value, for any other x value, the y's are different. So for 0, it's a negative 3 and a positive 3. They're different y's. If the y's are different, that is not a common point. If the y's are the same, it's the exact same point, that is your solution. Now let's look at an inequality. This graphing the inequalities gets a little bit tricky. But before we graph it, we still have to solve for y. So let's come down here and solve for y. Now remember, if I divide by a negative, I do have to flip the inequality sign. Fortunately, we're just subtracting the 4x, so we don't have to divide just yet. So I have a negative 4x plus 2. And I'm lucky, I don't have to divide by a negative at all on this problem. So let's plug in each equation. Well, the first one's easy. It's just negative 2. Make sure you use a negative sign, not a subtraction symbol, or it will give you an error message. So then I have minus 4x plus 2. Now the trick is, how do you get that inequality, that shaded region? We're going to hit the left arrow button over here until that cursor moves all the way over, and notice the little line outside the y1 is blinking. Now this one is a greater than. Which way does greater than shade? Remember, it's going to shade up. Alright? So I'm going to hit enter, and it gives me a bold line. I hit enter again, it gives me a triangle. That triangle means shade up. Okay? Now I'm going to go down to my other equation and over so that the line is blinking again. Only this one, it's a less than. Less than does what? Shades down. Alright? So I hit enter, gives me a bold. Enter, it gives me an up. Hit enter one more time, it gives me the shades down. So now I have it shading up and shading down. So let's look at the graph. And you'll notice that beautiful shading coming across the graph. So I can see that this region right here on the upper left-hand corner is the shaded region of my graph. So any point in this region and every point in this region is a solution for this system of inequalities. Now I could either express that as a domain and range, or we can draw the graph as is. And in our homework, we drew the graph.